Everyone, thank you for joining us, and welcome to Zygo webinar on MX 9.2 highlights. Get the most out of your metrology software. I'm Martin Fay, product manager for user experience at Zygo. I'm very pleased to be joined by my colleagues, Rich Poultar, who's an optical systems engineer, and then from the software engineering department, we have Jack Monades and Ryan Cardis. And we're very pleased that you can join us. Quick run through of today's topics. These are just some of the highlights from MX 9.2 shown at the left-hand side there. After each section, we'll have a brief Q&A, so please feel free to post your questions in the GoToWebinar interface. And any questions we don't get to live today, we will answer offline after the webinar. So with that, I think we'll move to our first topic, which is the patterns user experience as well as data review. And for that, I'll hand off to Jack.
All right, hello everyone. So my name is Jack. I'm a software engineer here at Zygo, and I'm going to be going over some of the updates for patterns. So for those of you who don't know, MX Patterns, it's an automation feature that allows one to set up a measurement at multiple sites. One can define a pattern of any shape or size and orient this collection of sites in space, set up actions at each site in addition to measurement, like running a script, loading settings, performing alignment. And so as you can imagine, it's perfect for measuring a tray of parts. And this feature is instrument agnostic, so it's available for both LAS and profile systems. So the first thing I want to do is just explore the types of patterns that this feature comes with. So there's three primitives. So those are rectangle, ring, and circular. For the rectangle pattern, you can set up the number of rows, columns, the spacing. There's also helpful GUI tools for setting up the spacing and the number of sites. And in addition, there's a setup option, which allows you to drive to the first and last sites and set up things like the spacing and the number of rows and columns from there. Here's the ring pattern. Similarly, you can set the number of sites, you can set the radius. This too has tools for modifying the radius and number of sites, and it also has a setup option, so you can drive to 3 sites and it will produce a ring perfectly matching those sites that you have driven to. And finally, there's the circular pattern. This you can think of almost like a semiconductor, so the sites are evenly spaced, but they do have this constraint with the exclude inner and outer radius. So we can create a donut shape if we set the exclude radius. So those are the 3 primitives, and then finally we have the most flexible type, which is the free pattern type. This allows one to drive to and capture sites completely arbitrarily, and you can also type in sites with this grid here. Part of the flexibility of patterns is it allows combining patterns. So any site you can set a child pattern to, and this can be through loading patterns from disk, importing a CSV, or using the quick builder tool. So I'm going to go over the quick builder tool just because it makes things very easy. So for example, if I wanted a staggered grid, what I can do is I can insert a quick rectangular pattern as a child of this pattern. So I can set the number of rows and columns for that pattern and spacing. And then because it's a free pattern, I can go and toggle these child sites. And so I can go and offset them a little bit. And then for each of these child sites, I can quick insert another rectangular pattern, this time of columns. And this will give us a nice staggered grid. So I can change the insert for all siblings. And so you can see how easy it is to create these types of patterns. And again, you can import at any of these sites, ring, circular patterns, or another free pattern. There's no limit to the depth. So hopefully, this really shows how flexible this tool can be. So now I want to show some basic quality of life improvements. This applies to all patterns. So we recently updated and decoupled the origin, location, and site alignment controls and made them much more intuitive. So if you want the pattern to start at the lower right, basically anywhere within the pattern, you can set the origin. And then within the site, you can, if you want to set the origin at the top left of the site, or the anywhere in the site, you can now set that easily. It's much less confusing than it was before. We also have a data viewer for all pattern types. So this is really important if you have a pattern of 10,000 sites. You can use this data viewer to modify sites, filter sites. So maybe you have a site with a special label you want to filter, and much more easily find the site that you're looking for and modify it. And then finally, if we go back to the free pattern, and if I load the free pattern I had in mind, there's a new settings library. So all the flexibility you have with MX settings, you can do per site now. So I set up a nice pattern for demonstration purposes, and this has two types of sites. It has pins, which have a bit of a step to them. So for the pin settings, I made a higher scan length, and then it has these mounting areas. And then these, the step size is smaller, so I made a smaller scan length, and they're much brighter, so I made a lower light level. So the settings library here, which can capture and load in settings, it gives you all the flexibility of MX settings per site. So hopefully this allows you to easily achieve whatever goals you have with whatever tray. So I'm going to go ahead and run this pattern for demonstration purposes. So again, it's 3 pins, and then it's these 3 mounting areas. So this will be nice and quick, and you see, we have a nice progress bar. This progress bar is especially nice if you are doing things like leveling and alignment. It really tells you where you are in the pattern. Similarly, the run pattern also has this nice summary, which if you're doing things like leveling and alignment, it's really nice to know, when those actions are going to occur, so you can modify the pattern to your needs. And so now that this is finished, we can look at the new data review panel. And you can see that the data review panel has all of our measurements at a glance. It has a nice screenshot of the measurement, and it has attributes and results for each site. Stored in a very efficient manner. You can easily look through them. It also allows you to add attributes and results after the fact. So if I want to say get like the valley or the peak location, for example, then I can add that after the fact. And if it's for a new site, so let's say I go to this site, this isn't loaded, so I can load and refresh these results. And we'll also work for attributes. So in this way, after performing a measurement, you can really do whatever you want with the data. You can save off all the sites, add new results and look at them at a glance, perform tolerancing, and finally, you can load the site data into the rest of the system. So if this one, for example, failed tolerance of some sort, you can load it into the system, switch to the analysis tab, and do any sorts of data processing and data analysis that you're used to with MX. So that concludes the overview of patterns, the new pattern types, the pattern builder, and the data review panel. So any questions?
Yeah, thanks, Jack. Some questions will come in. Two-parter, actually. So do these features, do they also apply to large aperture systems? And if so, with which measure modes?
Yes, so they're completely agnostic, so profiler or LAS. And the features are pretty much the same. The features are really only limited by the axes that you have available. And as far as, so LAS has a large set of measurement types. So this supports form and Acer form out of the box.
Okay, great. Next question. Is it possible to define multiple concentric rings?
Yes. So in the same way, so if we have this free pattern, you can add additional sites, and then you can, for each of the sites, you can then insert a quick ring under it and just vary the 2 radius. So you'll have 2 sites at the same location, but with different radius.
Excellent, thank you. Does patterns work with non-Zygo staging?
No, so it's only available for Zygo staging.
Okay. Last question we have here. Can I make a pattern for an ellipse shape?
So there is no built-in primitive for an ellipse, but you can, like in your favorite programming language, create a CSV and then import that CSV of sites.
Okay, great. Well, that's all the questions we have for now. If there are other questions, but we'll get to them either at the very end or after the webinar.
Hello, everyone. Thanks, Martin. I'm Rich Poltar, Optical Systems Engineer here at Zygo. And next up, we're going to take a look at the latest improvements to making CGH measurements easier. So CGHs, or computer-generated holograms, for anyone that has used those in the past, knows that they're generally a little bit more advanced, a little bit more difficult to use. So we'll be looking at the new features inside of MX, all attempting to make that easier to use. Primarily, CGHs can be difficult to use because you need to align a part under test with multiple degrees of freedom, and additionally have potentially multiple operators be aligning this complex measurement type, which can then lead to differences from one user to the next user. Even if your results look very similar, you might be getting a different surface map when using the CGHs. Another issue that we will run into and need to address when using a computer-generated hologram are distortion effects when measuring through a CGH, especially if you're doing any sort of sub-aperture polishing techniques that are typically used with Aspheres. It's really important to know that your surface error or your surface feature is laterally dimensioned at the right position if you're going to correct that in a post-polishing step. And we'll take a look at how we are doing that remapping in MX as well. So first, we'll take a look at a typical CGH measurement layout. Here we have a transmission element on top, and this happens to be a downward-looking vertical setup. So we say a transmission element that could be a flat or a transmission sphere feeding into the computer-generated hologram, which is a diffractive optical element that then will generate an aspheric wavefront to ultimately measure some part under test with a shape that is not a flat or a sphere, which we very typically will measure with a Zygo interferometer. So for today's demo, we'll be taking a look at a parabolic artifact we have here at Zygo, along with this CGH and its layout on the left here. So to give you an idea of the fringes we'll be looking at, you can see this layout has some rays in green here. Those are a collimated or plano wavefront that go out to the edge of our part and generate this fringe pattern right on the edge here, which is measuring a flat datum that has been ground and polished perpendicular to the optical axis of the parabola. So that helps us get tip tilt roughly aligned to start. Next, then we have in blue these rays here that are generating this cat's eye reflection or fringe pattern that goes to the center of the parabola, reflects back to our system, and then generates this fringe pattern just in here, just inside of that annular flat. Now, when these fringes are straight line and parallel, that is indicating that our Z position or position along the optical axis is set properly and our parabola is at the correct radius of curvature, basically. And then finally, the rays bundle here in red, that's the probably say the most important measurement or fringe pattern generated here on the right. That is our actual unit under test, or in this case, a parabolic measurement. So with that, we'll head into MX and take a closer look at the measurement type. So first thing to notice here is on the top left of our measurement setup panel, we have the CGH measurement type. So this will be new in MX 9.2. And the first step involved in measuring a part with a CGH would be either loading or defining a CGH design. So I'm going to go ahead and launch our CGH design editor. I already have a design file or a .cghx file previously loaded and prepared for this part, just for time's sake here. But on the top left, you'll see we are defining our CGH specific parameters. This is more or less defining the geometry of the test and any alignment aids that might be placed into the CGH. And then down the middle here, this is our part definition. So first we'll take a closer look at the CGH parameters right here. And the first one is defining your transmission element. In this case, we are using a transmission flat But if you're using a transmission sphere, you can see we have all of the Zygo spheres, as well as the option to have define a custom sphere as well, if you do have any of those. If I were to have picked a transmission sphere, then I would need to next define the TS, transmission sphere to CGH distance, that's grade out for a flat, followed by the CGH to part distance. In our case, that's 185 millimeters. And then the CGH diameter. So that is the diameter of the central null pattern of our part under test, as well as the retro inner and outer diameter. So these are defining the inner and outer diameter of this other brighter fringe pattern here. And that is helping us align the CGH itself relative to the interferometer tip and tilt. And for the CGH, you can see at the bottom here, the last parameter defines how much tilt you put in the CGH. So in this case, it's 1 degree. So now that our CGH is defined, we can take a look at our part under test. So for this would generally come from your specification or your design print. First up, part diameter, 75 millimeters. Then we can define our clear aperture of 70 millimeters. We are working with a simple circular aperture in this case, but if you have a more complex polygon shape or something that's non-circular, you can upload or import that as a CSV file as well. And then below the aperture definition, we just have the radius of curvature, negative 100 millimeters, and then the conic constant for a parabola is -1. Additionally, we would have the higher order aspheric terms if you were measuring a part that was defined with those coefficients as well. So once we've defined that CGH design, we could save that as CGHX or reload it here. We get a file name here for what has been loaded. But then moving on with the measurement, the first step we need to do is actually have MX calculate and detect the center position of the CGH and the part under test. So for that, we can go ahead and click auto calculate, and that's going to make a quick measurement and then overlay the inner and outer diameter of that retro pattern. So that's a quick check to know that we've detected the center properly. And in addition to that, we've also laterally calibrated the system correctly. So using that outer diameter we defined at the designer, we're also laterally calibrating through that step. Next, once that is done, we are free to then go ahead and run the auto alignment routine. So you can see the fringes, I've moved to a position just a little bit away from null. So I've moved an X, Y, Z pitch and roll, so 5 degrees of misalignment here. You can see that outer flat datum on the part is indicating some tilt, as well as a little bit of curvature in this region here, that cat's eye pattern I mentioned earlier. There's a little bit of curvature indicating some Z position error as well. So I can go ahead at this point and click auto align. So this will then go ahead and make a measurement, adjust the part position, the stages as needed, and then do an additional measurement and iterate until some final alignment. So at this point, you may see there are a few fringes left in the measurement. However, that is adjustable through a threshold. So you can tighten that up or loosen it as required. So you might have a faster or slower automated alignment, but definitely adjustable there. Once we've aligned our part, we can then go ahead and measure. So I'll go ahead and click the measure. So in this case, now we will take that measurement and then move over to look at the plots on the right-hand side of the screen here. So the top right is showing the raw input, and I'll point out the lateral scaling of this measurement. You see that's 57.2 millimeters in this case. So that's actually quite a bit smaller than the 70 millimeter clear aperture we defined in our design. And that's because between this raw input, we then move to the middle plot here with the surface deviation. Going from the raw input to the surface deviation is where we laterally rescale or remap the data. Now at this point, the data has been dimensioned properly so that if we have a high point over here and we're going back again to our, say, sub-aperture polishing tool, we know that is correctly scaled so that that polishing equipment then can polish the correct location Obviously, if you had said that was at 57 millimeters, you would make your part incorrectly. So then moving down from surface deviation ultimately to this plot on the lower right, we call this the misalignment removed map. And here we remove the residual error or residual misalignments in the previous measurement. So you can see in surface deviation, there's a little bit of tilt, probably a little bit of power potentially, or whatever the residual misalignments are in this map are then removed in the last step. Ultimately, we can go ahead and view a larger plot of that misalignments removed, so we can investigate this as well. And then additionally, below here, we can decide to analyze this with all of the misalignments or positional errors removed, or include them in our final map, and then process the data as needed, as you typically would in MX with all of the available surface processing controls and analyses that are already included in MX. So that does it for our CGH measurement type. And if there's any questions at this point, I'm happy to take those.
Great, thank you, Rich. Yeah, a few questions. One question is, what hardware do I need for AutoNull to work? And I guess, and the side note of, do I need a DMI?
Yeah, so you do not actually need a DMI for the auto alignment to work. Currently, I happen to be on a VFA Plus with DMI and high precision positioning system. But as long as you have a motion system, XYZ, tip, tilt, that is configured by MX, and as MX is aware of that, we can make this measurement and then make an adjustment as needed. So that would include instruments such as our VFA, or even our 5-axis mount when it is motorized and on a radius scale. We can also do the alignment in that configuration on an optical bench.
Okay, next question. Does this correct for the distortion caused by the CGH?
Yes, so the distortion correction, that would be another term, is for the remapping I had mentioned. So going from the raw input on the top right to this surface deviation plot, the distortion as measured through the CGH is also corrected between those two maps and in that step.
Okay, there's a question here, I think this is an opportunity to clarify a bit, is asking, why is there a concentric ring pattern? So maybe this is, I think this relates to the alignment patterns or the outer patterns on the CGH.
Sorry, a center ring pattern? Is
the
this one
concentric ring, yeah.
Yeah, so this fringe pattern here is that cat's eye pattern I had mentioned that's going from the edge of this position on the CGH just outside of our null zone to the vertex of the parabola. And when that is straight line and parallel, it indicates our Z position is correct. So I'll go ahead and just move off in Z a little bit. And you can see as I induce power in this measurement, you get curvature in that fringe pattern. So that can also be used to align in Z. And additionally, you can actually take this a step further if needed and say here where this looks relatively straight, but there's still some curvature in our part under test, you can compare the power in those two fringe patterns to back out radius of curvature or radius of curvature error from your design as well.
That's great. Yeah, okay, lots of questions coming in. So rest assured, we will answer them after the webinar, I think. Just one more question, I think. Can this measure freeforms?
Yes, so we can definitely measure freeforms if you have a CGH designed for a freeform. However, we are still working towards the auto alignment and the remapping features for freeforms. So the measurements can definitely be made with MX. We're just definitely still in development of the more advanced alignment and analysis of that. But I would definitely stay in touch with us and keep a lookout for that, say over the next year or so.
Great. Okay, I think it's time to move on to the next topic, which I guess I will lead.
Yeah, thanks.
Okay, so next we're going to discuss Asphere Plus analysis. And for that, I'll just show this screen here. So this is it refers to an analysis which can be done to fit and remove prescriptions from measurements of what I'll call Asphere Plus parts. So these are parts that include aspheres, torics, biconics, generally parts that have a prescription with some degree of symmetry, but even some mild preforms. And this supports measurements for VFA Plus, for CGH, as well as from optical profilers. So as much as possible, it is instrument agnostic. This data set I've loaded here is from a VFA Plus, and this would equally work for a measurement from using a CGH, as Rich just showed. And for those measurements, the data set includes an embedded design, the associated nominal prescription, with the part being measured. And so, these maps correspond. This first map here corresponds to a map of the actual part itself. It's a 3D representation of the part that was measured. The right-hand map, upper right-hand map here, shows the deviation relative of the measured part relative to the design. And then the lower right-hand map shows the rotationally variant component of the deviation. And that can help highlight defects potentially in the manufacturing process or other issues to deal with. So to speak a bit more about what this deviation map represents, this, as things stand right now, this shows the deviation between the measured map and the nominal prescription. So that is with no fitting. But if I want, I can fit, for example, the base radius. So I'll turn on the fitting function here. And now we can see that fit the best radius, there's a 0.5 micron deviation or error between the best fit base radius and nominal, for example. Now, if I want, I can also fit to other designs, besides the one that perhaps I had in mind at the time of measurement. So for that, I can switch to a manual entry. And for this example, let's suppose that we want to additionally fit not only the base radius and conic constant, but we also want to apply some aspheric coefficients, from the classical Asphere equation. So we can fit those, and we'll see that it does the fit, and then we see best fit coefficients for A4 through A12. So that's an example of a data set from acquired using a large aperture system, VFA Plus in this case. But we can also, this also will data in this case measured as a toric measurement done using a Z gauge. So this will support measurements done, using an optical profiler. Now, one thing you'll notice here is that measurement, is capturing surfaces beyond the toric surface itself. So we can apply some input pre-processing to clean that up. So here we'll apply a mask, and that will just extract out that central portion that we most care about. Of course, I mentioned this is a toric, not an Asphere, so this is a good chance to certainly go through some of the other supported surface types. So we have the Asphere type. There's a biconic, that's sort of like a toric, but you have conic constants as well as base radii that you can vary, or that differ between the sphere and cylinder axes. A multi-region sag table, that's a specialty surface type. Forbes polynomials, both the BFS or best fit sphere formulations as well as the conic formulation. Sag table, that's if you have a table of values, Z versus H. Simple sphere, and then finally here we are at toric. So I'll just reduce the clear aperture to be what we have here. And then we can, input the nominal values for the sphere and cylinder. Look at that deviation first of all. So you can see this is now showing the deviation between the measurement and nominal values for sphere and cylinder radius, or we can also fit those to get best fit values. And so now we see that the best fit values are, as shown here, deviating slightly from the nominal values. One other thing I'll highlight here is that the deviation direction that can be chosen as vertical, or Z, or polishing, shown as P, which is also the surface normal. And the difference in the maps is not all that extreme, but it's there. And the motivation would be Vertical Z would be good for if, for example, you want to put the deviation map into optical design software to sort of study the effects of the deviation. The polishing direction maybe be better suited if your intent is to use this as a hit map to further work on your optic. So that's a very quick overview of the Asphere Plus analysis, and I would welcome any questions.
Yeah, so thanks, Martin. A couple of questions here. Starting to sense a little bit of a theme, but first, can this analyze freeforms?
So yes and no. So I think this will analyze the prescriptions that are based on, I'll call them sort of symmetrical formulations. To a point, it will handle off-axis apertures and so on. But I think looking ahead, the freeform analysis is something which we certainly plan to extend and build on in the coming year.
Okay, great. And I guess, could you also talk a little bit more about what is an Asphere Plus, quote unquote, part?
Sure. Yeah, the plus is sort of a nod to the fact that we have Aspheres, but a growing number of high value optical services that can be described by ever more complex equations. So we've seen a few examples of those here with Iconics and Torix, as well as mild freeform. So it's really meant to also convey Zygo's stance that we're our overall suite of solutions, the CGH-enabled metrology, the VFA Plus. These are all solutions which are going to evolve to accommodate a growing number of optical surfaces.
All right, great, thanks. And next up, we're going to send it over to Ryan to take a look at the advanced profile analysis.
Yes, hello, my name is Ryan Cardis. I'm a software engineer here at Zygo, and I've been working on the advanced profile analysis integration into MX. And if you're unfamiliar with advanced profile analysis and how it can be useful to you, the quick rundown is that advanced profile analysis is going to allow our users to make a precise analysis on geometric shapes, which is going to improve your understanding of your measurements and also boost efficiency in your manufacturing processes. So I'm going to show off two different data sets, and I'm going to try and paint a little bit of a picture of how advanced profile analysis can be useful to you. So the first data set I'm going to show is this one up on the top right here. This is a multi-stitch profile of a cylinder, which is going to showcase a great use for advanced analysis, which is verifying a part based off of a datum or a reference. So here I already have the part loaded up. You can see the 3D view over here. So on this left side over here, this is going to be the datum. This is going to be the part that we are going to be verifying. And then down over here on the right, this is going to be our reference. So this is going to be the part that we're verifying against. So I'm going to make a very quick angle measurement. So we are going to create two segments, one at the top here and one over here. And then for our reference, I'm going to create one right here and one over here. And scooch this out of the way. And so very quickly, angle over here. And we're actually interested in the supplementary angle, but I'll get the two angles set up for you real quick. Let me click on this. Oh gosh, come on, click. Okay, well, it's not going to show. Let me click on it to showcase the supplementary angle. But so we are looking for around 131 degrees. So you can see on our reference over here, and you can see our datum comes in at 135.3 degrees. So depending on your tolerance limits, either this is okay or this is not. For us in this specific part, we were actually looking for around 5 degrees of tolerance. So this actually kind of works out perfectly. So this is a very quick, nice, useful way of analyzing your parts. And then this next data set that I'm going to show off is going to also be another amazing use for advanced profile analysis, which is going to be coming from a multi-fuel injector. So I'm going to load in my data, load in my correct sequence. So as you can see over here, as I go over to the mountains step, I'm going to show you the 3D view. So if you're unfamiliar with how some multi-fuel injectors are manufactured, There's a ball valve, which is just a conical shape with a ball lying inside of the cone. And this ball is going to help control the flow of fuel that's going into the part. So this means that it is absolutely crucial to ensure that the contact points on the ball valve are going to match up to spec. And advanced profile analysis is a perfect tool to use in this case. So we're going to be fitting a 1.5 millimeter ball to a 90-degree cone. And we're going to determine where the conical sidewall is tangent. So very similar, I'm going to create 2 segments, these bottom angles right here, 1, 2. And I'm going to create a circle, but I want to be a little bit more precise than just a hand-drawn circle. So I'm going to create a circle in contact with 2 segments. I'm going to click here and click here. And we're expecting a radius of 1.5 millimeters. So I'm just going to enter 1.5 millimeters. And you can easily tell very visually that we are intersecting on that conical sidewall tangentially. So you can see that this is a perfect fit. You know the part is in spec. So I can also show what it looks like if the part is going to be out of spec by very quickly. Let's say if we were expecting 2 millimeters, we can go over here and rather than 1.5, we'll enter 2. And you can see that it's not perfectly going on our segment, so you can tell that that's a little bit out of spec and it doesn't look just quite right. Yeah, so in the interest of time, I'm going to end there. If you have any questions, you can put them in the chat or you can speak to your local Zygo rep in order to learn more.
All right, thanks, Ryan. So one question here, can you have multiple slices on a single step?
So on a single step, no, you may not, but you can just do the backup plan of just having multiple steps. So you can do any analysis that you want, you just have to create more steps.
Okay, and is this like this question here, do I need to pay to use advanced contour analysis?
So yes, this is a licensed feature. You're going to have to talk to your Zygo rep in order to learn more about the pricing. But yes, this is a licensed feature, so yes, you will need to pay.
Yep. Okay. Can measured parameters be assigned tolerances?
Yes, that is a great question. So you can do tolerances. So if I just go over to here, my intersection is here. But yeah, so you would just click on this define tolerance limits right up here, and then you would be able to set any tolerances that you want. So let's say if I were to have our radius over here, I'd just be able to click on the radius. Click on it. But yeah, I would just click on the radius, go up to results, define tolerance limits, and then yes, right here you could set it up however you want.
Okay, one final question for now. What versions of mountains are compatible with MX?
So yeah, so if you notice, this piece of software in here is completely external to MX. This is actually a piece of software called Mountains Map, which some of you may be familiar with. And the earliest versions that we support is versions 9.2. But if you have version 10, then you're in luck because we support that as well.
Okay, thanks, Ryan. I think we'll hand off now to Jack.
Okay.
All right, hello everyone. So I'm going to be introducing a new tool called App Data Flow. And basically what this tool allows one to do is customize their app at the node level. So this can involve things like adding analysis tools to the processing tree. So for example, like our PVR or PSD analysis, you can add those to the end of the films measurement. Or you can add, for example, an additional sequence processing, branching off of the main map. It also allows reordering and removing processing nodes and adding some new processing nodes to MX that are exciting, such as the multi-loading node, which allows you to load multiple pieces of distinct data into MX at the same time. So this could be for comparison and analysis purposes, and a multi-processing node, which allows you to process multiple pieces of data in parallel with common processing options. So for example, like MST, if you wanted an auto aperture for each of the MST surfaces. So to give a brief illustration, I made an app here, and this app can, so I took our pattern data, and so I'm going to load 3 pieces of our pattern data, 3 pins into MX at the same time. So this is through the multi-loading PN that I added, and then I added a multi-processing PN after this. And what the multi-processing is doing a height clip, and it's removing low area. And so you see we have our 3 maps here, and we can look through them, and it's applying this processing to all of them. And then finally, we have for each of those maps, we're splitting it off into 2 different sequence processings. So we're using an FFT filter, and we're getting the low and high frequency components. So if you wanted to do additional analysis on these low or high frequency components, you could kind of use the split model for the 2 separate sequence processings. And this, in this case, it's FFT separating by frequency, but you could also imagine, 2 different surface processings, each having different masks. So doing analysis of 2 different parts of the data, or each having different apertures with auto aperture. And so finally, I made a workspace that just shows, for each of the 3 pins that we measured, after all the common processing, and then after splitting it into low and high frequency. So hopefully that gives kind of a brief illustration on what this tool can do. Here's an example of the actual interface. So the multi-loading node, this is kind of a tree of its own, common processing, and then finally splitting off into individual sequence processings. So the overall idea is just that this will allow both the apps department and more advanced users power and flexibility to make apps cater to pretty much any job that comes up. And that's it. So any questions?
Yeah, thanks, Jack. This looks like a great tool, and we do have a few questions. First, for the data multi-loader, can I load data of different sizes or from different types of instruments?
Yes. So in this case, it was just for patterns. But for example, you can load, any of the sample data that we have. Doesn't have to have the same camera, same instrument, anything like that.
Great. And one more question. How do these capabilities of the data flow tool compare with those to the existing surface processing?
Right. So surface processing, it has, 1 input, 1 output, and then there's a series of processing steps. This is kind of 1 step higher where it's working at the node level. So surface processing, that's 1 node. And so you can configure things like what would the input of surface processing be, where you want the output of it to go, how many you want. So it's working kind of 1 level higher than the individual surface processings.
Awesome, thanks.
Everyone, yeah, so I guess this last section will be kind of a bit of a collection of things that help, improve quality of life within MX 9.2. So I'll start with some new features that relate to the 3D display and maps in general. So I'll start by looking at the axes and the legend bounds. So this is something which has been, I guess, a long time complaint of some users, that they would like to be able to control the bounds of the legend to not be based necessarily on the range of the data, but maybe based on the range of the palette. So I'll give an example of that. Supposing you want to bound it so that the palette legend is shown down like that. So this can be useful for comparing data sets. Might have different, which might have a different range or have a different tolerances. And somewhat similarly, we can make the range deliberately larger than the data, and that can make it more obvious that data sets are being compared to a common overall scale. I'll put that back. Now, the other thing I wanted to show is some improvements to having to do with the 3D display. So we see I have this new tab here, and we can play with things like shading, brightness, and this is purely qualitative, but depending on the story you want to tell or how you want to present your data, this gives you more control over the 3D lighting and shading of your data. You can control things like the overall surface finish effectively of the data, the elevation of the light, the light angle, and so on. So again, this is purely for display, for presentation purposes, but this can help tell your story in the way you want to using your data. A few other options that have come up include you can display data as a grid. You can even, in this case, you can disable the surface plot and just have it like a mesh kind of display. That's an option. Again, it does not change the results, but it helps give you more options for how you want your data to be conveyed. And there also is the option for contour lines, and these can be controlled either as a percentage of the overall data height, or it can be an absolute value for height, depending on what makes sense for your data. There's even an option to show that as a projection underneath. So there's different options to let you show your data the way you would like. You can also do custom palettes if you like, to show again, whatever story you want to tell. These are also available. So that's a very quick demonstration of some of the new features to do with the plot controller. I also wanted to show some improvements with fiducials. So although it's a data set that illustrates that. So here we'll add some fiducials. I've chosen auto center, and you can see that when I click, and then we'll say we want to add fiducials where we have these gaps in the data, and you see this is auto centering. So first thing I'll show is that if I select all, I can click this button here to select all. Any properties which are common to all the fiducials will display here, and if I wanted to edit them in bulk, I can do so. Again, this is purely for display, but it's maybe making it easier to see the fiducials. If I want to rotate the fiducials, there's a handle for that. And you'll see now that the center of rotation by default is now the center of the data. This is in response to quite a bit of customer feedback in this regard. And you see that the angle of rotation is shown next to my mouse here. You can see that angle changing. And if I hold down the shift key, the angle will be constrained to increments of 15 degrees. So that's one way. Now, if supposing I wanted to rotate or in some way translate the fiducials by a more precise manner, I can click on this manipulate tool here. Now I have more options. I mentioned that the pivot point by default is the data center. That seems to be the most common desired center, but there could be other possibilities. This bounding box, this corresponds to how it used to be, in case you're used to the way it was before and you prefer that for some reason. You can also do a custom center of rotation. So if you have a particular center XY value you want to use, that certainly is an option. I'll go back to data center here. So let's supposing that we wanted to rotate, for example, by exactly 1/5 of a rotation, so 72 degrees. That can be done. And so also note that Control Z works. So I just went back to where it is now. So if you want to undo an operation, that is possible. Now, another common pain point with fiducials had to do with manipulating the data. So for example, if we wanted to rotate our data, so here I've added an angle of 50 degrees. If we apply that, you see that the fiducials follow the data, and I can change angles, and everything will keep track here. So on, and this applies to other really any step that pertains to or that in some way changes the lateral coordinates of the map. So translation or scaling, subsampling, all those operations, the fiducials will follow the data. The last thing I wanted to show for quality of life improvements relates to regions. Now, regions, in case you're not familiar with this tool, it's a way, it provides a way to take an overall data set and separate it into individual regions. So I'll load a data set to illustrate that. So in this case, we can do what's called islands segmentation, and then each an individual circle here becomes its own region, and that's that can be helpful. The let's load it again. All right. So then the option or the question then becomes one of how do we want to sequence or order those regions. And so before we had options to do with smallest to largest and so on, highest to lowest. There's a new option called raster grid, and in that case we can this works very well where the the data are organized in rows and columns, for example. So here I can choose the overall order of the sorting of the regions. And now we see that, we have things organized in rows overall, and then within each row, it goes left to right. And if I would rather think of things in terms of left to right as groups, then that's also an option. So we can apply that. To show that. And if I prefer a different, ordering within each group, this control here lets me toggle that as well. So that works, those built-in options work well for data that are, where X and Y are aligned with the natural grouping of things of these regions. Now, what if the whole overall data set is rotated? So I'll show an example of that. So here, obviously, the top options here of top to bottom, left to right, those aren't going to work so well. But we can do, one option is to do it automatically. It will automatically detect, the prevailing orientation. And one thing I'll do here to help clear these up, I'm going to add an area filter to exclude the small islands we don't want to keep. All right, so now we have islands we want, and it's detected that the rotation, the overall prevailing rotation is minus 30 degrees. And this is based on determining which orientation would give rise to the smallest overall number of groups. So you can see as you go through the order here, these are ordered nicely according to that 30-degree rotation. Now, the automatic determination might not be what you want. Maybe you actually want it to go the other way. So you can also say, well, I want to tell you what angle I want, and we can enter in our own value. In this case, it would be sort of correspond to the, the other direction, the orthogonal direction. And so now we can see these are sorted that way. So this kind of, this is a common request we've had for folks that wanted to be able to have better control over the order in which regions were sorted. So that provides that. So I think with that, I think we can go to a general Q&A.
Yeah, so thanks, Martin. Definitely a lot of questions coming in. And just a reminder to everyone, if we don't answer your question in the moment right now, we will definitely get back to you through email. Let's see. So first, I think we'll look at the patterns a little bit more. And Jack, a question about masks. Can you set unique masks for each site measured?
Yes, so as part of having the settings library, any sort of acquisition settings, including acquisition masks, will save and restore per site. So if you create a library of settings, each with a different acquisition mask, you can achieve that goal.
All right, thanks. And next question in regards to the advanced profile analysis. Do we need a separate mountains map license to run this tool?
Yes, so you would need a license in MX for the advanced profile analysis, and you would also need a mountains map license as well.
Yeah, thanks, Ryan. Another question related to that. Can this analysis be done across the entire profile and not just a slice?
So the way that it's currently set up, it's only done off of slices. So yeah.
All right. And then let's see, switching over back to the app data flow features. Jack, can the data multi-loader display results for each surface loaded?
Yes, so you can get the same set of results as you would for the main app for each individual.
And follow on that, will the multi-loader or the data flow tool in general, I guess, support scripting when released?
So for the multi-loader, there is scripting support for loading those individual data matrices and also clearing them. And then for other nodes, it'll be on a per node basis.
All right, great. And There's a lot more questions here, but I think that does it for today. So I'll just send it back to Martin, and we will get all your question answered through email.
All right. Thanks, Rich, very much. Yeah, so just to review, today we kind of went over some of the key topics shown on the left-hand side. Those are some of the key aspects of things that are new with MX 9.2, but there's lots more, and summarize a little bit on the right-hand side here. So I want to mention that, for example, for large aperture systems, we now have auto alignment using the line camera, and also auto alignment for Dynaphase. For optical profilers, ZipScan now works with extended scan. It also works with oversampling. Another highlight I'll point out here is that the MX help is now available in German and Japanese. And we have updated Japanese translations in the MX user interface. One question we got was, also I should note, was whether this will be available on YouTube. The answer is yes. Look for this later this week. We'll post it. So if you missed it, or if you have colleagues you think might be interested in seeing some of the stuff, please point them to it. Again, as Rich noted, we have lots of questions we didn't get to today. Our apologies, but we will certainly follow up offline. So fear not. And then finally, look for MX 9.2 in early January 2024. So thanks so much for joining us. Thanks again to my colleagues, Rich Poltar, Jack Boinodies, and Ryan Cardis for helping me out. And bye for now.